Okay, so again, we had our critical numbers and we were able to classify them using, what we used was the first derivative test, which was what I did in red here, basically. Hopefully that makes sense. Decreasing, then increasing, that makes a min. Increasing, and then decreasing, that makes a max. Okay, part G, intervals of concavity and inflection points. So here's my first derivative, which I found earlier. And then I'll find the second derivative, which will be 6 minus 6x. Factor out the 6. 1 minus x. Set this equal to 0. And we get x is equal to 1. So 1 is the only number dividing up my number line here. What should I say here? I should do test points, right? So here's my factored second derivative. So if I do, say, 0, which is over here, I'll go f double prime of 0 is looking here. I can see it's going to be positive. And then f double prime of, say, 2, that will be negative. So all this tells me that I have concave up here and concave down after x equals 1. Inflection point is x equals 1. Okay, the inflection point is x equals x is equal to 1. The corresponding y value would be, well, let's remember what f of x is. F of x is 2 minus 3x squared. I'm going to say, I think it's this. 2 plus 3x squared minus x cubed. Let's double check that. Yeah. Sorry about that. Okay, so inflection point is a point. It has an x value and a y value. So here's the x value. And the y value is, well, I plug 1 in here. And I get 2 plus 3 minus 1, which is 4. So the IP is 1, 4. Okay, we're going to put all this together now and try to get a picture of this function. So what I'm going to do is do the easy stuff first. Okay, I'm going to graph the inflection point, or plot the inflection point. I'm going to plot the max and min values here that I found here. Okay, so that's where I'll start. Now, here I got x is 0, y is 2. Here I got x is 2, y is 6. And here I got x is 1, y is 4. Okay, so these numbers will tell me how to draw my scale. Okay, you don't want to be doing a tiny little scale and having to erase, or even worse, having to do a very cramped drawing. So I'm going to use a nice big space here. Okay, I know we like to save paper, but I think we can afford to use some trees here. So I'm going to go with lots of space, eh? Why don't I go with 8 up here, minus 8 down here, plus 8 over here, and minus 8 over here. Okay, the IP was x equals 1, y equals 4. So I'll put some 4s in here. 4, 4, minus 4, 4. X equals 1, y equals 4. So x equals 1 is roughly here. Y equals 4 is right about there for my IP. And then I had a min at, what, 0, 2? Mm, 0, 2, which would be about here. And then I had a max at 2 and I believe it was 6. Let's double check. 2, 6. So 6 is up here. 2 would be here. So I'm going to max right there. So I'm going to max there. Let's zoom in here. Max here. Got a min down here. So I can just go ahead and draw these maxes and mins. Max here. I get a min down here. Now I have an inflection point right here, so my concavity should change. Now it is concave concave up over here, and it's going to be concave down over here. And it switches at my IP here, which I'll make a bit smaller. So I want it to go through this point, and I just want to connect the dots in an intelligent way. So my max here, min down here, connect the dots while respecting this inflection point. Okay, so I'm going concavity down, 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 down. Oh, and then it switches to up, 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 up. Oh, that didn't really. You know, it doesn't really matter too much. Let me try one more time. Down, 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 down. Down, 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 up, 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 up. Good enough. Okay, as long as if you label it, put the IP right there. So I'm aiming to have, you know, concave down here and concave up here. It's not so easy, but don't worry too much about that. And then I think it's going to be concave up, and it's going to be decreasing over here. So it doesn't really matter too much. Just draw something that's concave up and decreasing. And over here, if I check my work that I did in E and G, over here it's going to be decreasing and concave down. So it's just going to go like this forever. Put a little arrow to indicate what's happening. There is an x-intercept. Oh, I lost my x-axis. Just give me a second here. Put my x-axis back in. So there is a x-intercept somewhere over here, but that was too hard to find, so we didn't bother. All right, so that's the picture I get. Now, what I should do is I should go back through A, B, C, D, E, F, G, and make sure that everything agrees with what I've drawn here. So how can I do that? How about concavity? Concavity. It should be concave up before x equals 1, and it should be concave down after x equals 1. And that is indeed what I have, because here is x equals 1 right here, and the concavity is doing what I want it to do. Concave up over here, concave down over here. Intervals of increase and decrease. It was 0 and 2, and I found it should be going down, then up, and then down again, and that is indeed what's happening here. Okay, so as I said, with these graphs, sometimes you're just putting some dots down, and then connecting them in an intelligent way that respects your IPs, respects your maxes and mins, and respects the intervals you found, both of increase and decrease, and concavity.